So good afternoon from my side. My name is Karina Lehmal and I'm the head of product management at Greenmo Power. And today I'm going to talk about measurement equipment with you. And with measurement equipment, I mean the equipment that is directly measuring, so not the device that is converting the analog signals into digital ones. So in short, we're talking about this product. It's very cute, it's very small, it's basically a coffee cup for our energy grid. So why? Well, first off, because measurement equipment plays one of the significant roles when we make the energy transition into a smart grid and implement more digitalization. So as every company, Greenmo Power also has its vision for the future, and our dream is to put sensors, or also called non-conventional instrument transformers, into every voltage level of the energy system. And why do we think that? Well, because with the energy transition, we need more and more digital things in all the substations, in the ring main units, to really monitor, regulate, and control the grid. Because we have seen it, there are so many asset managements happening all around, and they cost billions of euros, of dollars in the US and Europe, and it's just not feasible anymore. And that means we have to put in measurement equipment and measurement devices, also called smart IEDs, into the digital system. So Greenmo Power is now 6 years old, so we're not really a startup anymore, but we're pretty young for a company in the energy sector, and we have now sold over 300,000 sensors that are all now implemented in the energy grid, really worldwide. And we have now over 6 product ranges. The first one's in gas-insulated switchgear for current and voltage measurements, next in air-insulated switchgears, as well as pole-mounted applications. So now, of course, the question is, why am I talking about measurement equipment? Because it's such a small component, right? But really, without this component, no protection device, no measurement device that puts in an algorithm, some kind of power calculation, can work, right? So we have those high voltages or medium voltages, but they cannot really go from the system into some kind of database cloud storage. So you need some kind of small thing that converts this big voltage or big current into a small value. And this is exactly where we come in. And why do we think that non-conventional instrument transformers are the right way to go? Well, because the energy efficiency, the resources that are saved during production, as well as the really small dimensions, and especially the price, speak for it. But I don't only want to give you some kind of buzzwords, I also want to put some numbers behind that. But first, let's give this whole topic some kind of background. So in the energy sector, we have 2 main challenges that we have to tackle in the upcoming years. The first one is the rising energy demand that is triggered by the ongoing electrification in all the sectors. And the second one is climate change. And it's a no-brainer that both things go hand in hand. So we have to solve both things at the same time. And of course, the ongoing electrification simplifies our lives and makes it really easy to now navigate everything. But what does it mean for the energy grid? We need way more energy than we have before. And that means that the generation of the energy and the transmission of the energy have to be thought over. So in short, fossil fuels and coal and gas, for example, are still the main energy sources. And those produce many greenhouse gas emissions. We have heard that probably today quite a few times. And greenhouse gas emissions, as we all know, make accelerated changes to our world's climate conditions. And this is not good, right? But we cannot change it immediately, but we have to make steps to do it. And this is where decarbonization comes in, where the smart grid comes in, and basically where measurement equipment comes in. So now over 130 countries have implemented some kind of energy plan, right? So for example, the European Union has issued the European Green Deal or the Fit for 55 goals. Other countries like the US have also their own task force and energy plans. And in all those energy plans, the main points are renewable generation, the decrease of the CO2 emissions, then the switch to alternative fuels, as well as electric cars and energy efficiency. And all those energy plans really talk about digitalization, but not one energy plan really defines what kind of measurement equipment is or has to be used to make digitalization happen. So nobody states what is the state-of-the-art energy equipment or energy measurement equipment that should be used. And naturally, there is no right answer because the energy transition is happening very quickly and our power grid has to solve many challenges at the same time. But why not start with measurement equipment that has a smart technology behind it and is very useful also in the long run? So when we think about measurement equipment, what would the perfect kind of measurement equipment be? Well, of course, it should be compatible to as many intelligent electric devices that are already on the market, and it should be very quick and easy in the installation. So in other words, a plug-and-play solution. And secondly, it should be also suitable for the measurement regarding the accuracy and also the application case. But now let's look a little bit further, why not? So with a smart grid, a certain percentage of 20 to 50% of all the switch gears have to be digitalized. That means that is a lot of measurement equipment. We can all imagine that, but really what is the number behind it? Let's make a very quick calculation. For every 100 households, there's one Ringman unit. And in the world, there are over 2 billion households. This gives us over 20 million Ringman units. And now to digitalize one single Ringman unit, you need around 15 sensors or 15 measurement equipments of all kinds, current, voltage, whatever. And now with the before-mentioned 20 to 50%, this gives us a number of 50 million to 150 million of measurement equipment just to get the 20 to 50% share. And yes, this is a really high number, but now what does this really mean? Our energy grid has to produce the additional energy for all those 150 million devices to work and to be operated, right? And also for production, the resources for all those additional measurement equipment must be there. And this is really crazy. So our measurement equipment must not only be able to measure and be installable, but it also has to be very energy efficient and it has to save as much resources as possible. So in other words, it should be green tech. Now, what do we have to measure in the grid? So we have to measure the active power and the reactive power, as well as the frequency. And according to a power equation, this means that we have to get the current and the voltage from somewhere. And this is exactly where now our products come in, or basically any product that can do it, because there are quite a few principles that do it, but not every principle is as efficient or resource-saving as the other. And now let's get to the numbers. So let's start with voltage measurements first. So for voltage measurements, there are really two principles. The first one is the conventional transformer. You have a product that is around 1 meter and half a meter wide and weighs around 15 to 20 kilos. So it's a big chunk of technology. Has a lot of iron and a big output signal. And then, on the other hand, you can have a non-conventional transformer based on the ohmic principle. So this has an ohmic divider inside, and you can basically throw it and nothing happens. So you don't have some kind of block that weighs 20 kilograms. You have a small product, which is easy, and you can implement it anywhere without having to utilize more space. Now, of course, there are also quite a few disadvantages and advantages, right? The first one is the energy efficiency. Again, with a big product, everybody can imagine that you need a lot of energy to operate it. You have iron, you have copper, you have windings, and this means you need around 100 VA depending on how many coils you have inside. This little product, it's small, it's cute, and it only needs around 0.6 VA in comparison. So when we compare it, you only need a little bit more than 10% of the conventional transformers. So the energy efficiency is really very high. Then next, you have also many advantages. For example, this one has no windings. That means you have no inductances, and this gives you a frequency independence, a humidity independence, and a temperature independence. So what does it mean? When our climate is really rising its temperature, this product won't give you some kind of accuracy problems, but the other product with all the inductances will do it. And now let's talk a little bit about the resources, because resources are important. So with the conventional transformer, you have basically 3 main components. The first one is the epoxy resin acting as an insulation. The next one are all the windings that are used in the product, because you have a high voltage that has to be transformed in a small one. And then you, of course, have the iron core. All these materials are very, very expensive, and the world does not have like a complete amount of them, right, that we need for 150 million sensors. So let's now look at the non-conventional transformer. The main material is the epoxy resin. This is the brown part here, because you have to kind of isolate it, because otherwise you hurt yourself. But then you have a small part, which are all the electronic components that are inside, and you have a silicon casting compound, which is on top. So basically, you have a different kind of material that is used. And now let's compare it depending on the size. So what does it mean? The conventional transformer is at 100%, and now we only need around 30% of the resources for this small little product. A nice change, right? And now let's look at current measurement equipment. Here you have 3 principles. The first one, again, is a conventional transformer. The next one is the Rogowski coil, and the third one is a low-power current transformer. I don't have the low-power current transformer with me, but it's basically the same size as this product. But the conventional transformer, again, is a bit bigger than 1.5 meters and weighs more than the voltage one, so around 35 kilograms. So it's a big block. And if you want now to digitalize a substation, you have to implement all those additional parts. And now where did you get the space? Because in those switch gears, there's not space for that when you have not designed it beforehand. And again, the principles are a bit different. For example, the conventional transformer acts or is still implementing the transformer principle. The Rogowski coil has an air core, and the low-power transformer has also an iron core, but with a shunt resistor, so that the output signal is very small and very nice for all the engineers in the field, so they don't hurt themselves. Again, let's look first at the energy efficiency. Well, again, you have a small product in comparison to a big one, so a small product can only win. So here, you only need around 30% of all the energy you need from all designs with a low-power current transformer, which is, again, great news when we think about the energy efficiency. Also, in comparison to a Rogowski coil, you do not have an active component. That means your lifespan in the grid is still 30 years and not 15 years with active components. So every utility company that implements the products doesn't have to invest so many times and in so many products. And now let's compare again their resources. Here we have the conventional transformer. Again, as the same as in the voltage transformer, the iron core, then the windings with the turns, and the cast resin are the biggest components. Then for the Rogowski coil, this changes because the windings are way more, because you have the air core, and you have to somewhere bundle up all the magnetic field lines. And now, in comparison, the low-power transformer, here, of course, you have the iron core, but since it is a way smaller product, you save 80% of all the resources in comparison to the other products. So, as a summary, and based on all those technical and all quantitative conclusions, it's pretty clear which kind of product is now really the best in energy efficiency, as well as in saving of all the resources. And it really makes only sense to use those kind of products in all the applications that we want with a smart grid. And now if we go back and remember the number of 150 million of needed measurement equipments, it only makes sense to use non-conventional voltage transformers as well as non-conventional current transformers to save in voltage measurements, in the power for that, and in the power for current measurements, but still have digitalization in your grid system. And with that, thank you so much for your attention, and I would like you to stop by at our booth or talk to us, because it's a very interesting topic that is really important for all of us.